Hello everybody. First of all, I want to start off with some few things. Our talk is obviously about microservices, like it's displayed here. And you usually, when you go to conferences, you see talks that say, hey, do microservices, microservices is great. This talk is basically about, yeah, microservices is a great architectural pattern, let's say, but there are some things that, well, we should know about it before going into microservices. So the idea is that things are not always as rosy as they seem to be. So I want to start off, but I really don't see very well here in the room, so I don't see exactly who raises hands. But I want to ask a question, and please don't be shy. Who has already worked on a microservices project? And say me. Hey, who has worked on a microservice? Okay. Oh, a lot of people. Who would like to work on a microservices project in the future? Me. Ah, okay. I see it's, well, also it's a little bit dark, maybe, that doesn't help very much. But let's get started. So let's talk about microservices. But before we go into this, let's briefly say a few words about me. My name is Dan, and I am a software developer. I'm working for a company called Amdaris. It's in Romania, in Timișoara. But I also founded my own company, so I'm one of those guys that kind of tries to do more, to do also stuff on their own, but also work for somebody else because, well, it's not that rosy with my own company so far. It's only 6 months old. But the idea of this company, Code Wrinkles, is to, offer trainings for those who want to learn software development or to companies that want simply to, grow their software developers and learn new concepts. I also run a blog. Unfortunately, the last month I didn't write too much on it due to some personal reasons. But I usually write fairly often. And I also use Twitter very often, so you can also follow me there. Now, this is about me. Let's now see or try to see what we'll talk about today. We'll have a really, really short intro into microservices so that we have really a common ground from which we go ahead. And then I will briefly explain what was the project, because this talk is entitled Microservices from the Trenches. So my idea was to bring a little bit out of my experience working on a microservices project and try to understand or try to explain the challenges that we faced as a team and how we tried to resolve them. And in the end, of course, I would like to draw some conclusions about, okay, how to do microservices, when to do microservices, is microservices only about writing code, and things like that. And there are, of course, a lot of lessons that me as a person and we as a team have learned from this project. But unfortunately, I don't have time to really, take a deep dive into all of them. So I will have to concentrate on 3 of them. So the first one was decomposing the services. So what services will we need basically for our project? Then messaging patterns between microservices, and then dealing with the whole concept or problem of an API gateway. So these are the points that we'll cover. Now that we start all from the same understanding, basically microservices can be described as something like this. This could be, for instance, an application for a car repair dealership. And this could be how the application for this car dealership looks like. So we have a lot of different services, like for vehicle management, customer management, workshop management and planning, and so on. We have, of course, a message broker, and this helps basically the communication between the services. And of course, we can have, on top of all of this, we can have the front end that we need. But to sum this up, basically what this means, it's, a microservice should be mostly small in size. And here, of course, there is another discussion. What does small really mean? Because, depending from where you look at things, let's say maybe if you have an application with, let's say, 10 classes, you could say, hey, this is small. But at the other hand, maybe if some architect at, I don't know, Facebook or Microsoft, whatever, of these big companies, thinks about small, maybe they, they think about some thousands of classes, and for them that is still small. So this is also a thing that has to be decided or discussed in the team. What does this small really mean in the end? But the idea is that basically each microservices should have a certain functionality and should be responsible only for that type of functionality. So it's kind of like the single responsibility principle applied to this whole idea of microservices. Then a service in this microservices environment should always or almost always be messaging enabled. What does this mean? It means that each service needs to know how to communicate with other services using the agreed mechanism, like a message broker or maybe direct messaging. We'll get into this a little bit later today. Then a service should also be bounded by a certain context. And what this actually means is that, as I said, the service itself should only do things that belong to a certain area for which we have a common, let's say, logical delimitation. And this, of course, can be bound to this idea of bounded context that we have from domain-driven design. And we'll talk briefly about that when we talk about service decomposition. Then, each service should be developed autonomously. What does this mean is normally each service is developed by a different team. And we will see that in the project that we worked on, it was not a very big company, so we really didn't have a team for each service. So we had to shuffle it a little bit. And this, well, we'll see that this was also a challenge for us. Then each service should be deployed independently. And I think that this is clear, that if we do some updates to a service, we have to deploy it, and all the other services should not be affected at all by what we have deployed. So this is really a very key point in having this microservices architecture. And then microservices should be decentralized. Of course, every service should only do what it is important for that service to do. And probably, or it should be built and released with an automated process. So these are kind of like, the things that should make up a microservices architecture. And then some of the benefits, well, of course, we have scalability because we can scale each service independently. So if, for instance, we have an application where we have an order management microservice, and we see that we have a lot of requests specifically for that service, then we can scale up the resources for that service only. And especially if you are using cloud environments like Microsoft Azure or AWS, it's fairly easy to do that. So this is a really big advantage of having this type of microservices architecture. Then, of course, we are more agile as, let's say, what feature release means. Because if I have a new feature for a certain service, I can, as said, deploy it for the service, and theoretically, all the other microservices should not break, so they should be exactly the same. So this gives us, as a company that has a product, gives us this agility that we need. Then another benefit would be availability, and this is clear because, of course, theoretically, everything could go down, and then in that case, we have a big problem. But there are also some cases when, let's say, we have a deployment for one of these microservices, and something goes wrong, and that service fails. So the idea is that all the other services will still work. So if we have a front end somewhere that kind of uses information from all the microservices behind to display something in that front end, basically only that part that renders the information from our microservice that has a problem will not work anymore. But all the other parts will continue to work. So this means that if one part of the application fails, the other parts of the application is still there. And this also, or all these three principles, or all these three benefits, what they basically do is that allows us as a company to innovate quicker. Because we can have smaller teams working on smaller things that can deploy different features independently. And everything here basically encourages us to innovate and to bring new stuff to the market as soon as possible. So what are the drawbacks of microservices? I'm sure that each of us would ask this question. So let's discuss it in the end, after I go through all the challenges that I faced working on this real microservices project. And now what I would like to do is very, very briefly explain what the project was about. So I am working with a customer from Sweden that has, I would say, an ecosystem of products for contact centers, so for call centers. Like they have workforce management, time and attendance that you see here, and I'll explain exactly what this does and so on. So chances are that if you know somebody that has worked in a call center or contact center, probably they have used some of the softwares that comes from this customer. Now, this application ecosystem is really, really rich. And another problem of this application ecosystem is that it's built upon different parts that are also very, very old. So we call it usually legacy, which means that we have, for instance, also desktop applications there that are written in VB6, for instance, or something like that. So it's really nothing very, very funny. And they had such an application that was called the time and attendance, and this application was basically used to measure if call center agents were adhering to their schedules, so when they took a call, when they finished it, when they checked in for work, when they checked out for a break, when they went home at the end of the day, and so on. And based on all this information, at the end of the month, usually, it would calculate a timesheet, which would basically exactly say how many hours each agent worked. And of course, this would also help to calculate a payroll, so how much should that contact center pay to that agent, although the payroll itself was done by a different application. So the goal that we had received as a team was to basically rebuild this time and attendance solution to meet modern software architecture standards, and of course their business needs, because they wanted to be more agile, to be able to bring new stuff to their application as soon as possible, and so on. So the decision was made not by me or by the team that I was working in, but by the customer, that we should use a microservices architecture approach. So when we heard about that, you can imagine that all in our team were like, hey, we're going to write microservices. That's cool. Because you usually go to conferences and you see about microservices, but a lot of times when you go to work, you just have to fix bugs, do maintenance, create maybe new small features for certain applications. And you really, it's not that often that you really get the chance to work on something like microservices, which is wow. So we were all very, very happy about it, and we couldn't wait to start to work on that. So let's see exactly what we've learned from this experience. And basically the first challenge that we had was actually right after we found out that we're gonna build a microservices application. And the first challenge was, okay, how do we decompose the services? What does this actually mean is, okay, what services do we really need for that? Do we need one microservice? Do we need two? Do we need 3, 10? How should those microservices be called? What should be their job? And so on. And usually when you go at talks and you read documentation about microservices, you see a lot of examples like online shops or kind of other things that are fairly obvious how you would do that. But in our case, I would say that it was not very, very obvious. On the one hand, most of the developers that we were in that team, we did not have a very real and deep understanding of the business. We still had, let's say, the Scrum Master that was also coding, that was from that Swedish customer, and that knew the domain very, very well, so he knew also the business logic. But all these type of things, well, led us to this problem, okay, what services should we basically create? And then basically we read a lot of things and tried to understand how or what would be the best way to decompose such services. And by the way, I won't dwell on this very, very long, because right after this talk, Christian Horsdahl will talk exactly about how do you scope microservices. So I will also attend that talk to see exactly what his perspective is, and obviously to learn something from it. But our research that we did and trying to understand, okay, how should we break everything up basically, how should we decompose the entire logic into different services. So we found out that there were basically 4 ways that we could do. The first one is by business capability, and this, let's say, model for scoping a microservices you will find in almost any reference architecture or I would say article about microservices. And what this says basically is look at the business, and each capability of the business should be basically a microservices. Now, of course, the next question for a developer is, okay, but what the heck is a business capability? Where does it start? Where does it end? The answer could be fairly easy, meaning that, for instance, a business capability is a unit that allows a business to perform a certain work. So if you look at the business, you have maybe sales, and of course sales as a capability is that department that, well, try to sell your product or services. Then you maybe have finances and as capability, and their job is to finance all the activities in that company. Then you have purchasing and so on. So it seems fairly easy. However, in our specific case, like we had a very niched application like time and attendance. How do you basically match business capabilities there? It's not really obvious, and it's also not really easy. Because that in itself is basically only a part of a business capability. So this model was not really the one that we were looking for. We have discussed things, how should we do that, taking this into consideration. And of course, well, we arrived at the conclusion that, well, there is nothing really important for us in naming or decomposing our services using the business capability. And I know that in his talk, Christian will talk exactly about this business capability as a first very important thing. But the next model that you will see anywhere when you read about microservices is decomposing by domain-driven design bounded contexts. Now, bounded contexts make a lot of sense. And of course, we could have a talk of 50 minutes about what bounded contexts are. But essentially, the way I see it, a bounded context is basically, let's say, a limited, I would say, logical space where a certain concept means a certain thing. Like, for instance, if I have a user, in the context of a user service, that user would have a first name, a last name, an email address, a phone number, whatever, all the user information. But when this user, for instance, comes and works and checks in, the service that would handle, for instance, when did he check in, for that service, the idea of user is just basically a user ID. That service really doesn't care about what the user looks like in a different service. So a bounded context, once again, is the context within a certain word has a very specific meaning. And in terms of programming, I would say that is maybe a class that has a certain number of properties, let's say. Okay, so we went ahead and we decided, okay, this would be a good approach for us. We have maybe also individuated some ways in which we could do that. And what we found out is that, okay, we had that timesheet service, and the timesheet service was, thought as the service that would be the one that would aggregate all the different check-ins, check-outs, and so on, and create a timesheet for a certain planning period, like a month or 2 weeks or whatever. So we already know that, okay, we have a bounded context in which all the different concepts mean a very specific thing, like what is a user, what is a customer, what is a time punch, what is whatever. And all these concepts in other services had different meanings, meaning that they had different properties. So we had one bounded context. But then when we thought further, we noticed basically that, okay, this is actually the only real bounded context that we would have in this entire application. Why? Because this is basically, the entire business logic of the application. Because the application is, as I said, a very, very niched one. It should simply take into consideration all the times that agents came to work, answered calls, went for break, and then calculate the timesheet at the end of the planning period. So this is what the entire application was supposed to do. So the application itself, as a scope, was, I would say, fairly or rather limited. But of course, in order to support this type of service, like the timesheet service, what we needed was, of course, a lot of other services that would kind of support this microservice. What does this mean? And we have in microservices also this concept of supporting services. What this actually means is that we needed probably a bunch of different other services. There were more or less simply CRUD services. Like we had an account service that was responsible for creating, updating, deleting accounts. We had like an employee service that was responsible, of course, for creating, updating, and deleting employees. We had further a time punch service. A time punch, in the way we defined it, was simply I started to do that. So that specific instant when I started to do something, that was a time punch. So we needed we thought that we need a service to kind of take care of this. So then we went on and basically we found out that there are some different articles where they say that, well, when you decompose basically services, you could also, simply use some verbs or nouns that in a certain way define either what those services are doing, like shipping, serving, ordering service, whatever, or by nouns, and this would mean that, create services that would have something like names like account service or employee service or things like that. So the idea is that, or our conclusion was that it's basically, not really possible to only take one of these approaches and really decompose all the services that you would actually need. Because there are a lot of questions that we had during the entire discussions, like how do we identify a bounded context? Because we had this strange thing, okay, but do we really have only one bounded context here? And in the end, we decided, again, after some discussions, that yes, it was actually only one bounded context. But then, of course, there is, okay, how do you decompose? Do you use verbs or nouns? Do you can we use business capabilities or things similar to that? So the idea is, or what we've learned from this, is that when you start to work on a microservice application, maybe you're the one that you design it from the scratch, maybe, or are part of the designing process, then of course don't take, let's say, a certain pattern and try to match everything only regarding to that pattern. As a general conclusion to all the experiences that we had is that, probably this applies in general to programming, but foremost in microservices, there is not really, only black and only white. So you take this and you do it, and you do it like that. No, it's a lot of flexibility. So the idea is that you have basically to be open to understand exactly what options do you have to decompose the services, and how would you proceed then. But the most important thing is that you as a team you should be consistent with what we have here. So let me basically show you here briefly what we have done here. You're not seeing this. Sorry for that. No, let me try like that. Oh, okay. Sorry. So what we have here is, here it is only one solution. It is in Visual Studio. We are working mostly on .NET, but I'm not really showing some really deep C# code here. But it's more for an idea about what we have done. In reality, we have several solutions. We don't have anything together, but we have put everything also together for things like conferences or demos or something like that. So what we see here is basically that we have this time sheet service, TA timesheet it is called, and this timesheet service is basically the one that is defined by a bounded context. And we can see that because for this timesheet service, we have different other projects like the data access, like domain models, like domain services. So it's basically like the onion architecture that we know about. And it's basically, in the end, the real such service that has all this type of stuff around it. So it's the only real bounded context that we end up of having here. But then, as said, we have a lot of other supporting services like TA account, and this service is responsible for handling a certain account. And as you can see, the logic or the amount of code that we have in this service is fairly small, I would say. So it's mostly CRUD operations, and the idea that when a new account is created or updated, these microservices should emit a message to the message broker, and we'll talk about this just right after. And all the other services should then decide what to do with that message. But this is basically everything we have in this account service. And similar, we have services for employees. Like we have also agreements. Agreements is something like a contract with each agent. We have also the employee. We also have this time punch service, which basically we found out should theoretically be also part of the timesheet service, because it's basically the same bounded context. But in this solution, we did not adjust, or we did not port the project to this TA timesheet. And then we have the TA API gateway, which we'll talk about a little bit later. So you see that basically what we found out is that, okay, this approach that we started to have was really important. But if you think, let's say, on a longer period of time, this time and attendance application that we can build or that we started to build with this microservices approach could be only a first step, because slowly they want to take all the other parts of their business logic, of their entire application ecosystem, and build microservices out of them. And in that case, of course, at that point, right now we have only this TA timesheet that is a bounded context, but at that point we will have several other different bounded contexts that we can basically maybe also try to bring together. Okay, so let's go further with the second lesson that I've learned is, messaging. And messaging is, in my opinion, or in what I have seen in a lot of conferences or YouTube videos or whatever other materials about microservices, almost nobody is really taking seriously this idea of messaging. So when you go to read about microservices, everybody says, hey, you have services that communicate with each other through a message broker. Great. Seems easy enough. But then when you start to really, implement the services after we have scoped them out and we start to implement them, and, we have to implement this type of messaging. So, things are not always that easy also in that case. Because what it happens is there are a lot of questions that you should actually basically think about. The first question that is basically discarded in most of the documentations or readings that you can make is the idea that maybe a microservices makes a direct call to another service. And it is assumed when we discard this option that you make a REST API call. But now we have also gRPC, which is very, very important. And what if for certain things, like, let's say, simple queries, maybe services can communicate directly with each other without the need to use a message broker? So maybe this is also an option that in some circumstances you can take into account. And then, of course, there is the second option. Let me go also to the next slide where we have the, three main options, where you can have this async messaging, where you usually also use a message broker. And basically what you do here is that you send some information every time something happens. And how other services react to that is the responsibility of each service. So this is also fairly easy and straightforward, but we'll look into the complexities of it just on the next slide. But then there is also this other model, like transactional model. Like, this is a model that you can implement, for instance, in cases where things are really, really critical for you. What would this mean is that before you send a message, it would also use a message broker, but before you send it, or send it to that message broker, you store it in a database. Like today at this hour, this message was created, and after you stored it in the database, basically you put it on the message broker or on the message bus, and then all the other services can react to it. The receiving services, on the other hand, also have to store that message in the database and then emit an acknowledgement to the service that emitted the message. Like, okay, I have received it, everything is okay, or nothing is okay, whatever. So this is also, well, a very valid approach for very, very sensitive information, where you really need to make sure that that everything is easily retraceable. So let me jump into the second option, or commonly the option where you use a message broker. And of course, there are several types of message brokers there, or companies, or libraries. What we decided to use in the end, I'm not sure if it is the best, but for us, it was very okay. So we could achieve everything we needed. It was RabbitMQ. And the entire problem when you're working with a message broker, there are really a lot of new concepts. We see here basically only 4, but there are also other concepts, let's say, besides those 4. But all these concepts are suddenly something that you as a team have to take care about in your application. So basically, who is the producer of a certain message, and what basically distincts a producer of a message of all the other services that are basically the receivers. Then of course is what exchange do we use? So an exchange is usually basically in the message broker, that part that basically represents a queue or a communication between different services. Now, exchanges generally could be configured in several different, can be configured to behave in several different ways. And we'll discuss some of that ways, because you can have here different messaging strategies. So basically, what happens if my account service just created a new account? It should put a message on that broker, or send it to that message broker, but how will that message broker handle it? It could maybe do a fan out and send it to all the other services. You could maybe have like topics and subscriptions, and you can then simply put that certain message on a certain topic, and all the subscribers to that topics would take that message and do something with it. Or we can have a direct casting, so that the message broker sends a certain message directly to a certain service. So these are all different options that we have on these message exchanges, and each of these options basically have different, I would say, implications that also from a design perspective, but also from let's say very practical software development perspective, because you as a developer, you will need to code against that, and this is also a very important thing. Then of course we have the different queues, like for each service, what we would end up to have is probably a queue for each service, and an exchange that kind of orchestrates all the queues or only a subset of the queues, and so on. So the idea here is that basically adding a message broker to this type of application basically adds a crazy amount of complexity. And Andy, that had a talk here right before me, also talked about that complexity and said that everything adds complexity. And yeah, it's true. But some things, well, it adds some complexity, like toggles, okay. Not really, really bad. You can, however, also turn them off at a certain point, as he said. But in our case, this is not something that, okay, it adds complexity for now and then it disappears. It's something that it adds complexity and it will basically never disappear, and the complexity will basically grow with each microservices that you will add to this message broker. So yeah, it's not that easy, because you will start to see also at times that, or what we did at the beginning, of course, is like the principle, keep it stupid and simple, no? We know it, and we said, okay, we apply this principle, and you know, what we will have is basically only one exchange, and we will do a fan out. What a fan out is basically, as I said, you receive a message to the broker sends it to all the queues, so to all the different services. And each service, depending on the message type, I will also briefly show some code about it, will decide what to do with it. It could basically also disregard it, so it's not important for me, it doesn't interest me at all. But of course, when you start to really have a lot of messages, you will see that, well, the performance of your message bus will decrease. And in that case, you will be obliged to add that complexity with different exchanges, with different patterns for different types of services and so on. And that complexity will in this case basically never disappear. So let's briefly look into the messaging part of what we have here. First of all, we have here a common library, which is the infrastructure messaging. And this could be, well, viewed like from the domain-driven design perspective, like the shared kernel, or being as a part of the shared kernel. And what we do here is basically, well, we have some classes here, like what is a message, what is an event, and so on. But what we have here is first an interface for a message handler. So what should a message handler do? And we have here a message publisher. So what a message publisher should do. And of course we have also a callback function that could be used basically when you try to do something. And let us see how this works. So let's go first to this TA account service. And in this TA account service, if we go here to this startup.cs file, and here if we go in the, where is it, configure services, it's register RabbitMQ. It should be here, yeah. And basically what we do here is that we add to this application a service that is, well, of type RabbitMQ message publisher, because in this case this account will only publish messages, or this service at least will only publish messages. And then of course if we go in a controller, like the account controller, when we have a new request to create a new account, we can see here that, okay, if everything is okay, so if the model validation is correct, what we do is basically we can create a new account set object which takes in this message type and this account update. So this is basically the type of the message once we put it in the queue. And of course we put here some information, basically all the information that the account service itself needs. And what we do afterwards is, okay, basically we use that message publisher and we publish the message to the message bus. So this would be the publisher. If we go to TA employee and if we go to startup, this TA employee is the service that handles employees. Just a clarification, in our project account, what it means is basically a customer. So you can think about accounts from a business perspective, like you have 3 accounts, like, I don't know, HP, that was mentioned also earlier, or a DevConf, whatever. You as a salesperson have 3 accounts. So you can see it like that. So each account, of course, can have different employees. So this is why this employee service, when it creates a new employee, needs to know to what account that employee should belong. So this would mean that the employee service should be able to handle, or to handle messages that come from the account service, because that account service is the only source of authority when it comes to updating accounts. So what we have here is basically is that in start RabbitMQ, here we can see that in this employee service, for once, we have first, we register a service that is the message publisher, because the employee service also publish messages. But what we have is also a message handler. And this is basically, this creates a new message handler. And what this does is, of course, that once we receive a new account, or once we know that there is a new account, then basically, we need to do something. And here we have also this event collector class. And here basically this is the callback. So every time we will receive an event, RabbitMQ will call this method that we have here. And in this case, for instance, it will look like if the message is of type account updated, then it will write it to the database. But if we go, let me briefly go here, and here is the difference. Is that in this case, okay, the object ID is what we need to store in Mongo. Then we have an account ID and name and settings. But you see here that the account in the account service had also other information, like is this account active or not, how many employees does it have, or whatever. So this basically means that the word account doesn't really mean the same thing for the employee service and for the account service. And again, what you see here is really the very, very basic implementation of such a messaging strategy, where you simply do a fan out. So you publish a message, it will be fanned out to all the queues, or to all the services that you have. And each service then would decide what to do about it. In this case, for instance, this service would handle only if the messages are of type account updated or agreement update. All other message types, if they arrive to this callback, they will simply be disregarded. So nothing will happen. But you can already see that this adds really a lot of complexity and on the messaging part, we are still not really done to say, let's say, we are not at a point where we say, now we are really happy with how it is. Because it's simply always doing something, adding something, depending also on the use cases, on the loads that we have, and so on. Okay. Let's go then further. We just have 7 more minutes, but it would be sufficient. The third point, or this is also another thing that you very seldom will read in documentations about microservices or hear about at conferences, is that, okay, you have a lot of different microservices. Most of the time, microservices expose some REST endpoints, and then everybody, who wants some information from the service should just call those endpoints. However, this brings a lot of problems for consumers. First of all, because let's imagine we want to build a front-end application for our microservices that we have in the background. This would mean that our application would need to know the exact host, IP address, port, whatever, for each service in order to make a call to that service. And there are also a lot of different other things that, are making out of this scenario not something that is really desirable. So there is this concept or real microservices pattern, which is the API gateway. What does this actually means is that, okay, it's basically you create an abstraction that you put in front of all your microservices, and everybody who wants to get an information, like about accounts, it calls the gateway. The gateway should then know where to go to retrieve that information. If you want to call for the employees, you call the gateway, and the gateway should know where to basically gather all that employees and then return you the needed information. So basically the gateway here would be, like the entry point to our entire microservices application. And this is, really great. But when we're starting to really, look into it, we found out that, such a gateway should do a lot of things. It should be able to proxy requests, so to know exactly where to find all the other services. It should be able to make service discovery, so to discover services easily when you don't know exactly the IP address or something like that. For instance, when you deploy to Kubernetes or whatever other environments. Then it should also be able to aggregate responses, because my front end, for instance, it would need maybe to make a call, but it would need some information about accounts and some information about the employees. Like if I want to get an employee, I want to also see to what account it belongs. So this would mean that the front end should make two different or two separate calls to the API gateway. One will fetch the information about the account, one will fetch the information about the employee. So the idea of an API gateway is that it should also be possible to aggregate responses. So if you want to retrieve an employee, it should know that, okay, I should also retrieve the information for the account. So that the applications that need or that use that gateway should not do two or more different requests for receiving some information. What we also wanted, we came to the conclusion that we need, the API gateway should be able also to do header transformation. What this means, it means to add headers, remove headers, whatever. And the scenario that we used for this was basically the part where we used the authorization and authentication. Because each request will go through the gateway. So if we have this central point of entrance or this gate, basically this means that we can enforce authorization there. And then all the other services, they don't really care about the authentication and the authorization. But of course, the idea is that we have to let's say, transfer this information from the API gateway to the services. Okay, how or is this user authenticated? What permission does he or she have, and so on. So this is why the gateway looks or does the authorization, looks into Joe tokens and so on. And what it does, it builds headers out of it with all the information that all the other services will need. And there are a lot of things that API gateways should be able to do. And of course, there are a lot of different options on the market. All major cloud providers have such gateways. There are also some third-party libraries that have that. Also, Kubernetes has this option. But there are some drawbacks. You have a technology debt because you are really tied to a certain technology. When you want to move out, it's your job. Have fun. But it kind of constrains what you can do, because I would like to do that. Yeah, but it's not supported by the gateway. And we tried to use firstly the Azure API gateways, and we came to the conclusion that a lot of things were not possible that we actually wanted to have. So what we found in the end, and this is a solution that is clearly for the .NET world. It's basically a library that by now is also backed by Microsoft, so you also see it in the official documentation. And it's called OSLOT. And this OSLOT library is basically, or does all these things that I mentioned earlier. So till now, we haven't found one thing that this OSLOT library couldn't do. So one thing that we needed and that this OSLOT library couldn't do. And the really very, very cool thing about OSLOT is that you basically don't have to write any code. It sounds crazy, but in a very simple scenario, it's really true, and I can show you that. Let's go. We should have here the TA API gateway here, and if we look at it, we have a middleware that does something with the location header, but and the options, which is an options class, so nothing really special. But besides that, we basically don't have anything. It's only the starting classes for ASP.NET Core, like startup.cs and program.cs. But what we have here is this file, oslot.json. This is the configuration. And everything you need to do, basically, you do in this configuration. And now I also have another talk. It's not here at DevConf, but you can find it in also on YouTube, where I talk about OSLOT and everything that it can do, how it does it, and so on. But the idea is that you basically, for most of the things, there are some complicated scenarios like service discovery or other things where you would have to write some code. But for the most part, basically everything is done in this configuration. So in the oslot.json.file. And here you specify for each request, so each request that comes to the gateway is seen as an upstream, as the upstream. The downstream is then the service to which we have to redirect it. And as you can see here, basically in downstream host and ports, you can provide several. This means that also can also do load balancing and stuff like that. And what we do here is, for instance, we do this add headers, which is also a configuration that basically instructs to also look in the claims of the token that you will find on each request if you find it. If not, it will simply return unauthorized. Look for the account ID and put a header with account ID and the value. And the same, the employee ID and the value. And this is basically the information that all the other services will then use, extract from the headers to know exactly for who should they do a certain thing or not. And of course, we have several services with different endpoints. So yeah, our configuration is like that. It's even not the biggest configuration that you'll ever see. But for, in our opinion, this is really, really important because, well, we have this option to really use this very, very powerful thing or powerful library that at least helped us to do a lot of things, and we really didn't have to do anything. Here, the conclusions is, well, of course, as you can see, microservices adds really a lot, like really a lot of complexity to our application. The idea is that it's not a bad thing. It could work, but for instance, in our project, this project was certainly not a suitable project for a microservice approach, because the complexity that we had to handle simply outnumbered all the pluses that we have for such a small service. And this is a phrase that I also, heard by Dino Esposito at a different conference, is that before deciding on going for a microservice architecture, try to ask yourself if it's really worth it or not. So, is it really worth to go for microservice architecture? If yes, okay, then let's do it. But if all the complexity really doesn't cover all the benefits that this approach will bring to your application, then a regular n-layer application, even done like following domain-driven design, would be perfectly fine. So it's not like something that only very cool applications are microservices. No, you can have very cool applications that are not microservices at all. It only depends on what they need to do, how fast, for how long, and well, where. Everywhere in the world or just in smaller locations. So that's it. My time is up, but if you have some questions, I'm open here. So you can come here and chat with me. And I will also be around today, tomorrow. So whenever you would like to talk, just come to me. And I'm also very chatty, so we'll have a nice talk, I guess. So thank you very much for your patience. And I really enjoyed being here in Krakow. And I really hope that my experience maybe would also help you, or maybe help you when dealing with other microservices projects. So this being said, I really wish you a great conference forward. And once again, thank you very much.